So the biggest challenge for me tonight is to try to talk about kinetics and transformation in a slide presentation with no video. So let me talk vividly about motion and you can imagine what's going on. My journey into this idea of kinetics began with a simple question: what is it like to sculpt with motion, and how do we make systems for people to be able to do that? The idea behind this robotic system which I've created, which is called Topobo, is that we can actually use a programming paradigm that is physical in nature, and we can engage our bodily knowledge and the transformations that we have inside of our own selves to be able to create and learn about the mechanics of the real world. The programming paradigm is simple. It's a single button interface. Plug it in, move it around, it remembers what you do, you play it back, and then suddenly a very simple set of motions creates a very complex behavior, creating walking creatures, etc. And we can start to think about how complex geometries can be created through motion through time. So that's looking at the nature of crystal structure and how we can sort of think about our bodily nature inside of mechanical robotics. So geeks always want to see about what's going on inside. We've had literally 1,000 prototypes of this thing, moving from very, very crazy distributed electronic systems into a very simple modular robotic system. And after 3 years, fast forward 3 years, lots of manufacturing development, we now have a system that's out in the world in museums and is now for sale actually at topobo.com. But this idea of transformability is not just about kids, and it's not just about learning science and physics. The future of robotics is not just about humanoid manifestations of robotics, but also looking at how we can have robotics embedded in our environments abstractly, our products. And I've developed a system for architects and product designers, as well as fashion designers, to be able to work with this idea of programming transformability inside of material structures, in both rigid and very soft material structures. And this nature of moving kind of kinetic transformability into a soft structure and figuring out how it relates to our bodies, I've now developed a kinetic transformable mesh, which is like a textile that can take the form of your body and be able to record a shape and then and use that for future generations of robotics. So this idea of actually taking transformability and dissecting the mechanical nature of the body is not just about robotics, but it moves into fashion. And this first as a piece of performance art. This idea that we can start to think about how can we actually harness the mechanical energy of the body. And this is a piece called piezing, which actually uses piezoelectric materials around the joints of the body, following the lines of non-extension, to harness the mechanical motion of the body into electrical energy and be able to store it in a battery. New materials, embedded materials, and engaging our own kind of bodily concepts that we're already using to create energy for a new kind of mobile lifestyle. Also moving into new ideas in our environments. What's the nature of the duality nature of light as both a wave and a particle? Step on this transformable surface in Tokyo. It takes the LEDs of the surface, moves them into the water next to it. And another interface which I developed with Dewey, a condensation display using puffs of water to create a display on the back on the back side of an acrylic display, like a programmable bathroom mirror. But this has really led to my real passion, which is about algae. And I fell in love with algae as a biomaterial, as the future of transformability is really about looking at how algae as a biofuel can take us both from the future of our alternative energy paradigms, how can we actually grow our own energy, and how can we install it in our homes, in our urban environments, and also to use it as a display material, to start to think about, well, algae is actually a beautiful bubbling material that as it grows changes color, and we can map that Pantone display that like we can map any other sort of Pantone nature, Pantone color. And so I now am the CTO of an algae to biofuels company, which actually works on the real world problems of scaling up algae to biofuels. working on light distribution inside of large volumes and actually sinking carbon dioxide and wastewater treatment into growing our algae and then actually creating a real renewable resource. But I haven't actually lost that nature of, how do we get it into our environments for real as a design material? What does it mean to actually have it be part of our environments where our energy is actually surrounding us at all times? So, thanks very much.